Hello everybody and welcome to this video. In this video we're gonna cover the Cambridge International AS and A-Level Syllabus for Information Technology 9626, specifically for databases. In this video we're going to basically cover all the MS Access stuff. So that means we're gonna cover 10.1 and we're gonna cover 10.4. We are not gonna cover 10.2, 10.3 or 10.5. I've translated this into my very own checklist and we're going to go over these points one by one. If you're looking for a specific topic in MS Access, you can use this table of contents to find it. Remember, it's not enough just to watch the video, but you need to get some hands-on experience as well. So I recommend that you follow along with the video. I've tried to keep the video as short as possible, so if you are following along, you're gonna have to pause the video quite often. In addition to watching this video and following along as much as possible, I also recommend that you do some exercises. You will probably be able to find exercises in whatever book you are using, and you can also go to the Cambridge website for specimen papers. So let's get started. First thing we will talk about is data types. But before we do, let's very quickly talk about how to just create a brand new database. Let's start off by starting MS Access and creating a new blank database. And I'm going to name my new database School. Pick an appropriate folder using this button. I'm going to leave it as it is and I'm going to click on Create. And we immediately jump into a table view. We see one column which has an ID number, and we have something here that says click to add. And I'm gonna first of all save this table. We have got table 1, and I'm just gonna press Ctrl S to save it. And I'm gonna name it student. This table is gonna contain a list of all my students. We have one column already. Each column is called a field, and I'm going to add a new column. It says here click to add, so who am I to argue? And I'm going to add a short text column. It's called field 1, and I'm going to call it first name. And then I'm going to add another short text, and I'm going to call it family name, surname. After that, I'm going to add date, and this is going to be the date of birth. So we've created a brand new table. We have no data yet, and we have 4 columns. Each column is actually called a field. And the first one is going to be a number, the second one is going to be a name, and it's going to be short text. The third one is going to be a name, and it's also going to be short text, and the fourth one is going to be a date/time value. The first one is a number, specifically it's an auto number. That means it's going to be filled in automatically. We also have field validation, and we also see that this one is supposed to be unique, so we cannot enter the same value twice. Let's see what happens when I enter some data for the first name. I'm going to enter the first name, and then I'm going to press tab for the family name, John Johnson. Date of birth, 15 April 2000, or how about 2010? You see in my computer it's an American format, so let's put it rather months first and then day. Always be careful with the months format. So here we see our first data. ID is an automatically generated identifying number. I'm going to rename this to student ID. Next, we're going to add a new student called Mary. And we're going to add one more. Now, we are in the data sheet view, and we can see the data, but we can also go to the design view where we can design the table. And over here, we can put the field name and the data type for each field. By the way, each column is called a field. Each row is one data entry. So we can see that data types could be anything. It could be a short text, a long text, for example, a description, a number, a data time, a currency, a yes or no value. All sorts of data types can be set like this, either in the design view of a table or in the data sheet of a table. We can click on the column, click on fields, and change the data type up here. Which means we can check this off. We can set the data type. Next, I want to talk a little bit about key fields. So going back to the design view, we see a little key up here. That's the student ID. If I click on it, I see it's a primary key. It's a unique identifier for each student. As our school grows and grows, it's going to become more and more likely that we have students who have the same first name, like two students both named John. Then we won't know which student we're talking about when we're looking him up in the database. And if we have brothers and sisters attending our school, also the family name will not be unique. Two students will have the exact same family name. And if we're very unlucky, it might be possible that we have two students with both the same first name and the same family name, so we cannot even use their full name to uniquely identify them. So to avoid this kind of bad luck, we will use a unique identifier for each student, and this is usually the primary key. If you want to set one of these fields as the primary key, it's very easy. Make sure you're in the design view of a table, select the whole field, click on primary key over here to switch it. Or if you want to make a combination of two fields as the primary key, you can select both. Select the first, hold down Shift, select the second, and then set both of the fields to the primary, and this is what's called a combination key. But I'm going to set it back to student ID. Next, I want to specify here which classes each student is taking. So to create a second table, we click on Create Table. And I'm going to save it straight away so that I can give it a name. And I'm going to create short text called class. And each class name. It's simply a list of classes, and each of them has a unique identifying number. I'm also going to make a list of teachers. I'm going to make a table containing teachers. Create table, save it straight away. Short text. First name, second name, family name. Full-time. A full-time can be either a yes value or a no value. And I'm going to populate it with some dummy values. John Smith, typical teacher's name. And now I'm going to go back to the student table, and I'm going to give each student a homeroom teacher. And instead of using the name of the homeroom teacher, I want to give the teacher's identifying number to the homeroom teacher. Now I have one table for students and one table for teachers. So I'm going to go to my database tools, and then I'm going to go to relationships, and I'm going to create a relationship between the student and the teachers. Here we have the list of the students and each of the fields related to the student, and here we have the list of teachers. And I'm going to say that each teacher can have multiple students, and each student has only one homeroom teacher. So I'm going to take the identifying number from the teacher table, and I'm going to click and drag it to where it says homeroom teacher. So I'm just going to click on create to create this relationship. So remember, each homeroom teacher has got multiple students, but each student has only got one homeroom teacher. So this is what's called a one-to-many relationship. We also have one-to-one relationships. So for example, we can create a new table, Control S to save parents. We'll say, let's call it primary guardian. Name. Telephone number. Email. In fact, I changed my mind. Let's rename this field to contact name, and let's rename the table to primary contact. And let's add in some values here. Each student can have only one primary contact. So we're going to add in 3 primary contacts. In this case, we are going to create a one-to-one relationship with student and primary contact. To create a one-to-one relationship, we first need to add a new field using lookup and relationship. And we are going to pick the primary contact, and we're going to pick the contact ID. And we're going to name it contact ID. And click on finish. Next, make sure we have our new column selected, and click on fields, and make sure indexed is selected, and make sure unique is selected. To summarize, what we have just done is we have created a new field in the contact table, and we have limited the possible values in 2 ways. First of all, we can only pick a value that already exists in the student ID column from the student table. And secondly, we cannot pick the same value twice. So for example, if we link the same guardian for both John and Simon, we get an error message. After that, we can go to relationship and we can show our tables again. And we can pick our primary contact and add it. And you will see there's automatically a relationship created. If not, just click and drag from the primary key to the foreign key. And then I right click on that and click edit relationship. We double check down here and see that it's one-to-one, as we expected. Next, let's create a many-to-many relationship. As we know, one student has many classes and one class has many students. We have already got a class table and we already have a student table. So next we're going to create a new table which links classes to students. Let's go to create table and let's go to design view. And we're going to start with the first name, which is going to be a link ID. And that's going to be the primary key of this table. And next we're going to have a student ID. And next we're going to have a class ID. And let's make sure that the data type of both is set to number. And now let's add some data to this table. And we're going to have a look at student number 1. Student number 1 is taking geography and math. Let me just close some of these other tables so it's not too busy on my screen. So student number 1 is taking geography and math. So geography 2. This is the identifying number of the student and this is the identifying number of the class. The second link also involves student number 1 and he's taking mathematics. Remember, 3 is the identifying number of mathematics. The next link will be link number 3 and it involves student number 2. And I think student number 2 is taking English and student number 2 is also taking computer science. 7. Next we go on to the third student, Simon, who is taking 3 classes. He's taking English, physics and IT. So that's gonna be 1, 5 and 6. So now we have a linker table and we want to use this linker table to link the student in the relationships. We're going to link the students to the classes. So let's add our classes table. Oops, 3 times is more than enough. We got our classes table and we also want our linker table. So we're going to link our student ID to this linker table. Student ID to student ID is one too many. Let's move this down here and this up here. And we also want to link the class ID to the class ID. One too many. So we've set up 2 or 1 too many tables, which ends up with student classes having a relationship of many to many. So in other words, the table student and classes have a many to many relationship. And we have set up this many to many relationship by using this linking table. So we've talked about entity relationship diagrams. This is an entity relationship diagrams and it connects different fields in different tables. We also talked about primary keys. The primary key is a unique identifier for each table. We didn't talk about foreign keys, so I'll tell it to you now. Foreign key is the primary key from another table and we use it to create a link. So in this example, the student table has a field named homeroom teacher, which is used to identify which teacher is their homeroom teacher. In the student table, the field homeroom teacher is a foreign key, and it's linked to the primary key in the teacher table. A compound key we talked about, remember? We can combine, if we want, the first name and the family name together to be a new primary key, and if we use more than one field, it's called a compound key. So we learned about what keys are, and we also learned about how to set keys. We also learned how to create a one-to-many relationship, how to create a one-to-one relationship, and how to create a many-to-many relationship. Next, let's talk about the difference between a flat file and a relational database. That's an easy one too. Essentially, each of these tables is a flat file because it's just a grid with rows and columns. That's a flat file. In this case, we call it fields and entries, but in fact, it's nothing more than rows and columns. However, when we link them together, it's a relational database. A flat file does not really need to worry about keys and primary keys and foreign keys and compound keys and relationships and stuff like that. So it's not really as efficient as a relational database. However, when you have a small amount of manageable data, or data, whatever you want to say, there's actually 0 point in creating a relational database. So if you're just sending somebody like a list of 10 names, there's no need to use a relational database. But if you have like a list of 1,000 names, all of them you have to store contact information for, and grades, and which classes they're taking, etc., etc., the data becomes unmanageable or difficult to manage. In that case, you want to use a relational database. Next, let's talk about referential integrity. You may have noticed that when we create a new relationship between a primary and a foreign key, we have the option to enforce referential integrity. If we click on that, in the student table, we will not be able to assign a teacher to that student unless that teacher actually exists. Let me show you what I mean. I'm going to go to my students table, and I'm going to add a new student named whatever you like. And the homeroom teacher is going to be teacher number 5. And I'm going to click on here, and it says you cannot add or change a record because the related record is required in table teachers. In other words, I'm trying to assign teacher number 5 as a homeroom teacher, but teacher number 5 does not exist yet. When I add number 3 in the homeroom teacher, it works. Next, let's talk about queries. Right now, we only have 4 students in our table, so we don't really need a query because we know all 4 students personally. But let's say our school grows and grows and we get hundreds of students. It's going to be quite useful to use searches and filters. So in order to do that, in MS Access we need to use queries. To create a query, we click on Create, and then we click on Query Design. Include the student table, and we're going to include the teacher table. And then I'm going to click on Close. And now, down here, we have a list of all possible fields we can include in our query. First of all, I'm going to include the student name, first name, and the student family name. And I also want to know family name of the homeroom teacher. Let's say we want to find John. We have one student named John, and we want to look up his family name and his homeroom teacher's family name. You just type John down here, and then you run the query. And here we have all students named John. We have only one. Once we've run the query, we can save it by pressing Ctrl S. I'm going to keep the name, it's query 1. In fact, let me rename it now that I think about it. Next, I'm going to add another student. Then I'm going to go create a new query. Again, I'm interested in the student, and I'm interested in the classes that that student is taking. And I want to include the student's first name and the student's surname. I'm also interested in the class name that the student is taking. And now I want the criteria M star. Star is what's called a wildcard. It means I want the first letter to be M, and star can be anything. It's a bit like the Jolly Joker in cards. The Jolly Joker can be anything. So it's going to find both Michael and Mary, because those are the two students who have a first name starting with M. Let's save this query. And let's see what the results are. Instead of running, you can also click here on the Queries tab. And here we have both students starting with M. Let's sort it by name. And we see all the subjects she's taking. She's taking all the subjects. There must be something wrong in the entity relationship diagram. That's because if we go back down here to the design view, we have nothing linking these two tables. So let's right click, show table, and add the linking. And now the query should work. It works, but what we forgot again is that right now Michael isn't taking any classes. So let's go to the linking table and give Michael a course. Michael's student ID is 5. And let's say Michael is studying IT. And let's go back to the query and refresh it by going back to design view and running it again. And now we have a list of all students starting with M, and we also know their class name. Let's save this query and close it. That's it for simple queries. Let's talk about complex queries. Let's create a new query using the query design. And again, let's talk about students and teachers. Let's talk about the student name and the student family name. And we're also going to show the teacher family name. A complex query is just like a simple query, but we have more than one criterion, that's all. So for example, let's go to our students list. For example, let's list all students whose name starts with both M and whose family name starts with a C. In this case, we will only end up with one person who is Mary Contrary. And it's going to exclude Michael Banks, because even though his first name starts with an M, his surname doesn't start with a C. So how will we set that up in? We just have to say M star over here and C star. Let's save the query first. And let's have a look. Only Mary, right? Let's say we want to have all students starting with M or all students starting with T. So it's going to list everybody whose name starts with M, and it's going to list everybody whose name starts with T. To do that, we need to do it the two criteria not on the same row, but on two different rows. So we add more than one criteria. this is going to include all students whose name starts with M, and it's also going to include all students whose name starts with T. Right. One more example. Let's say we want all students whose name starts with M or whose surname starts with S. In that case, I can remove this and just add a second one over here. Notice that I have still used two different rules. That will ensure that this OR takes effect. So we have both students whose first name starts with M and students whose family name starts with S. And that's all there is to it when it comes to complex queries. Next up, we talk about static parameters and dynamic parameters. So far, we've only been using static parameters. We determine static parameters while we design the query. For example, M star means starts with M, and here the parameter is M star. But we can also set up a dynamic parameter. In this case, the parameter will be determined by whoever runs the query. To set up a dynamic parameter, we just use square brackets and some guiding text. For example, I'm just going to add square brackets and I'm going to say type the name of the student. And then I'm going to run the query. Type in which student I'm looking for. And this is the only student we have named Michael. In this case, it is the person who runs the query that determines the parameter. It could be Michael or any other name, and the user can even use wildcards like star and question mark. You can even use things like smaller than and larger than. For example, if you're looking for all students with a birth date before a certain date. Next, let's talk about wildcards. So for example, if I want to find anybody with 4 letters in their first name, I can just type question mark, question mark, question mark, question mark. I have to use quotation marks to make sure that the query knows it's a text. So this will find anybody with 4 letters in their first name. Right, we found both John and Mary. But what if I want to specify that the second letter needs to be an O? Then I can just do it like this. This will find everybody where we have 4 letters in total and the second letter is an O. And that's basically wildcards. And we already learned about and or. But what about smaller than or equal to? We're going to add the birth date of the student. So to list all the students who were born before the 1st of March 2010, we just simply use the smaller than operator. We are listing Simon 3 times because he takes 3 classes. In fact, I'm going to just remove this table, and then he should only be listed once. Right, we have 3 students who were born before that date. So that explains how to use wildcards like the asterisk and the question mark, Boolean operators like and or. Remember, either put them in the same row for and or in multiple rows for or. And we also know about smaller than or equal to or greater than. Next, let's talk about nested queries. A nested query is running a query on query results. So for example, here we have our query result. I end up with 3 values. What if I want to run a query on this table? That's possible too. So I'm going to create a new query and I'm going to include the results of my other query, which was this one. And I want out of all these guys to list all the students whose name starts with an M. And let's see the results. We have only Michael, right, because it's a query within a query. It's a query that uses this mini table as input. And that explains nested queries. Next, let's talk about how to find and remove duplicate records. So sometimes it happens that we add a duplicate record by mistake. For example, if we have a lot of information, it can be quite hard to find the duplicate records, but luckily for us, we've got a wizard which will help us find the duplicate record. Just click on Create, Query Wizard, and here we have one specifically for Find Duplicates. In which table are we looking for duplicates? In this case, we're looking in the student table. Any student which has a duplicate first name and a duplicate family name should be identified. If we are also interested in who the homeroom teacher happens to be of this student, we can show that too. Because we might have put Michael Banks in twice with two different homeroom teachers. I don't want to delete the wrong record. And then we can name our query and click on Finish. And here we have found Michael Banks. Once we found Michael Banks, we can just right-click and delete one of the duplicate records. And let's go back to the student table, and we see that it's been deleted. In fact, if we can close and reopen the student table, we see no trace that he was ever in there. So that's how we find and remove duplicate records. Next, let's talk about summary data. But before we talk about summary data, I just want to create a new table called a grades table. For now, I have populated it with only two students, student with ID 1 and student with ID 2. And I've added the fields subject ID and grades. To add a percentage grade, I first need to go to the design view and make sure that the field size is not integer, which means a whole number, but rather single, which means decimal values. So if you're following along with me, make sure the field size is set to single. And then up here we can set the format to percentage, and we can add in some grades. And up here we can format the number of decimal places. Next I'm going to fill out all these grades, and after that I'm going to link the table together in the relationship view. So as you can see, this grades table also creates a many-to-many relationship between students and classes. So if I want, I can get rid of this linker table. Next, we're going to create a summary query. To create a summary query, we just start as usual. We want to include the student ID. And in fact, we also want to include the student name and the class name, so we need to add these tables too. Let's add the student table and the class table. And then let's rearrange it so that it's a bit more clear how the relationships go. And now we can pick any fields we want down here. Let's say first name, and class name. And of course the grades. So what we want to do is we want to calculate the average grade per student per subject. So we're going to click on this sigma up here, And then down here, we're going to pick average. And we click on run. As you can see, the students have been grouped together by first name and by class name, by subject name. And the average of each grade for each group has been calculated. So in other words, the average score for John for geography is 66%. Let's save this query by pressing Ctrl S, pick a query name. And as you can see, we don't only have average which we can choose, but we can pick a whole bunch of functions which we can use, like count, max, min, etc. We can also create crosstab queries to get more information in rows and columns. We easily create a crosstab query using the query wizard. Start up the wizard and choose Crosstab Query. From which table are we going to create the query? Next, we pick the fields we want in the rows, in this case subject ID. We can pick more than one field. Let's also pick student ID as well. And then we pick which fields we want in the columns. In this case, let's pick date. And we would like information for each month. Finally, we pick what field we want a summary of, and in this case we're going to calculate the average of grades. So looking down at the preview, we see we're going to get the average grade per subject per student, and we're further going to break it down into per month. And we set the name of the query, but I'm going to keep it as is. So here we have a monthly overview of each student's grades. So that's it for queries. Next, we're going to learn about validation. Using validation, we limit the possible values that anybody can enter the database. Unrealistic values ideally should be rejected. To add validation, pick the table where you want to add validation and go into the design view. Then pick the field where you want to add a validation test. And down under General, we see validation rule and validation text. In this case, I'm going to add a simple rule. I'm going to add larger than 1st of January 2022. We see that when I press enter, Access immediately autocorrects me. We also add a simple text message in case somebody inputs invalid data. When we finish, we get a warning that it's going to check the whole table with this new validation rule, and that might take time. But since our table is so small, I'll just click on yes. And let's add in a new value, and let's see if it gives us an error message. So I add an invalid value, and I get an error message. But if I add a valid value, no error message, which is great. Now we have grades. As you can see, the grade can be 110%. That doesn't really make any sense. I want to limit my grade to be between 0% and 100%. So we go back to design view, and under validation rule, I pick larger than 0 and smaller than 100%. In fact, Access gets confused. In fact, I need to use 0 and 1. Where 1 would correspond to 100%, and for example 0.75 would correspond to 75%. And we also add this error message. And when we click on datasheet view, we are reminded that we have to save, and we're asked again if we want to check the table with our new rules, and I click on yes. And as you can see, we do in fact have invalid data. And we have the option to undo, but I'm just going to go ahead because I know it's this 110% over here. When checking if data is valid or not, we can also compare two different fields. To demonstrate, I will create one more field called date of report. You know, the date when students get their report card. And we are going to set up a validation rule to make sure that the date of the evaluation is before the date of the report. First, click on the properties sheet. And then on the right hand side, we see a properties sheet related to the table as a whole. In other words, the properties down here are related to the field, while the properties here are related to the table as a whole. Next, we click on these three dots to open the expression builder. And using the expression builder, we can easily add the expressions we need. And as usual, we add a useful validation text as well. Let's test it. Yep, it seems to be working. Incidentally, we can also access the expression builder down here. The expression builder is very useful because it has access to all these functions and these rules, so we don't have to commit them to memory. But even though we don't have to memorize them, I do highly recommend that you get some practice using the expression builder so that you'll be able to use it smoothly and efficiently during the exam. And that's it for the validation rules. Next, we're going to learn about sorting data. First of all, it's quite easy to sort data when we create a new query. In the query design view, we can easily use this row to specify that it should be sorted. In this case, we sort by name first and then by subject. We can also sort in the data view of different tables. Just click on the little symbol on the top right hand corner of each column and we can sort smallest to largest or largest to smallest. We can also sort multiple fields. For example, if we sort the grades first and then the subject ID, we end up grouping together each subject, and for each subject we have the grades listed from lowest to largest. And that's all for sorting data. Groups just means that when we sort two fields, then the one ends up being grouped and the other one ends up being in order. Next, we're going to talk about calculated fields. Calculated fields are pretty simple. We just simply go to click to add and add a new field, and we pick calculated field. In this case, we want to calculate a number. And here we have the expression builder again. We'll just use it to build a simple expression, in this case grade divided by 10. Remember, the grade is in percentage, so if I just divide by 10, I'll end up with a grade out of 10. In fact, that's not at all true, because if you recall, it's actually stored in Access as a number between 0 and 1. So we don't need to divide by 10, but we need to multiply by 10. But before we fix it, let's first name our field. And then right-click, modify expression. And that's much better. We can change the format up here. And that covers calculated field. We are also going to talk about calculated controls, but that's related to forms rather, so we're going to postpone that. For now, we're going to talk about importing and exporting. To export is very easy. Just select the table you want to export first and then go to External Data and pick either Excel or text. You will get this pop-up window where you can just specify the file name. Or if you pick text, you also have to specify what you're going to use to delimit the values. In this case, I recommend you just stick with comma. That's the simplest. And now that we've exported two tables, I'm going to import them again into a new database. So first, let's create a new database. And I go to External Data, New Data Source, From File, Excel. And then it's just a question of picking the right file. But of course, you need to make sure that the file was in the right format or an easy to read format in the first place. So best it's just in a very simple table with headings and data. If you're not using Excel, for example, if you're using OpenOffice or LibreOffice, it's best to export your table into a CSV file, a comma-separated file. In this case, the first row is the field title, so we want to specify that. Then next we want to go through each field and we want to make sure that the data type is set correct. And when it comes to the ID, it's not a bad idea to make sure that we specify that it's the index. Next, we want to set the primary key, and in this case we already have a primary key, namely ID, so we'll set that. And we can also set the table name. Importing from text is done just the same way. In this case we're importing a CSV file, and as you know, our file is delimited because that's the way we exported it. But if you don't know what to do here, then why not pick one of them and have a look at the preview to see if it makes any sense. So for example, if I picked fixed width in this case, when I click on next, I don't get any columns. So I'll click on back and pick the other one. So now we see the columns are showing up properly. And once again, we set the field names, etc. We also pick the primary key. In this case, we choose our own primary key. And there we have it. We just imported two tables. So that explains the basics of import and export. But that's basically importing and exporting raw data. What we didn't talk about yet is how to export a report. To create a simple report is quite easy. You just click on the table and then you click on Create Report. Once you have a basic report, you can modify it by clicking and pressing Delete to remove fields, and you can move around fields and resize them. In this example, I'm rearranging and modifying the basic fields to end up with a 3-column table. Normally we want to be more specific about what enters in our report though. So what we would do is we would create a query first to decide what data ends up in our report. And then it's a simple method to simply select our query data instead of a table and use that data to generate the report. For example, we've created a summary query about the average student scores, and we're going to use that to create a report. And if we design our query well, we hardly have to do any formatting after that. In this case, let's just change the grades to percentage rather. And press Ctrl S to save and give our report a name, and you see it appears in the column here. We can also change the page setup of the report in this tab. And in the bottom right hand corner we have 4 views: report view, print preview, layout view, where we can change the layout of the different fields, and design view. In design view we can change the relative size of these fields. For example, I can increase the size of the page footer or of the report footer, and under design I can add all sorts of fields. And I can use the property sheet or the formatting tab to change the format of the report. It's fun to mess around with these fields and see how it looks like in the print preview. And when you're more or less satisfied with how your report looks, you can export it with this button up here. And it exports to a nice PDF file, like so. If we want to make a more advanced report with grouping, the best way to go is with the wizard. We can pick a table or a query as the source of our report, and we can pick which fields we want in our report. Then we click Next, and we select the grouping. In this case, we want to group the student name, and for each student we're going to show the average grade for each subject. And then if we like, we can pick if we want to sort in ascending or descending order. And finally, we can pick the layout of this report. We can pick stepped, block, and outline. And of course, we can set the name of the report. Once the report has been created, we can fine-tune the layout. For example, we can use a format bar to decrease the number of decimal places in this field. So now we have all the grades for John stored together and all the grades for Mary stored together. I can make summary calculations for each student too. For example, we want to calculate the average for each student. To do that, we first go back to Design View, Design, Group and Sort. Make sure Group and Sort is active. And then down here we can add a footer. We want to add the footer to the section. In this case, the sections correspond to each student. So we will have a footer below each student's details. And then in the footer we can add some summary data. So for example, I'm going to add a label. And then I'm going to just copy this field and rearrange it like so. Let's see how it looks like. So you see that in the footer of each section we have the name of the student. In addition to the name, let's also add the average score for each student. So we go back to the design view, give ourselves just a little bit more space in the footer, and from the field list we're going to drag and drop the field. Remember, if you don't have the field list open, you can open it up under Design, Add Existing Fields. Next, we want to change the format, so we go to the Layout view, select the field we want to format, go to Format, and set the right formatting. In this case, it's giving us the very first results of the average of grades field. But we can also use a formula to give, for example, the average, or in this case, let's give the minimum of the grades. To do that, we go back to the design view, and we put an equals here, and write min, open brackets, and then use square brackets to refer to the field, and then close brackets. And let's update this label too. And resize this. And this is the result. And that's how to create reports and export them as PDFs. Which brings us to the end of import and export data. Next, we're going to talk about entry forms. To create a basic entry form is quite easy. We just select the table we want to create an entry form for and go to Create and go to Form. And now we have a very basic form which we can use to add new data or to change data. We save the form by pressing Ctrl S and we will appear in the left hand side under the Forms heading. As an example, let's use this form to add new data. First, we create a new record, add in some values, and as you can see, some of the fields fill in automatically, like this grade out of 10 and the ID number. To make sure that the data gets updated, better click on the Refresh All button up here. When it comes to forms, it's very important to arrange the fields in a logical way. We can easily resize and move form elements by clicking and dragging. If you want to resize, just hover over the edge of a field and look at the cursor to make sure it turns into 2 arrows. Then you can click and drag. If you want to move a field or a group of fields, make sure that the cursor looks like 4 arrows and click and drag. We can easily insert new columns and new rows in the Arrange tab with these buttons up here. And then we can click and drag the fields into the new rows and columns. And we can also delete just by selecting and pressing the delete key. To good thing about using forms is you can make it easier for the user to correctly enter data. To do that, first make sure you have a form selected and then go to the Design tab. Then go down to this triangle down here and make sure Use Control Wizards is active. Then you can add any of these form elements to the form just by clicking on it and then clicking on the form. And it will open this wizard box, which will guide you through the steps of adding the element. To demonstrate, let's go back to the previous form we were working on. First of all, let's add a combo box in which we can use to pick the student ID number. A combo box is just a drop-down list. And in this case, the possible values are just the possible student ID numbers. So we can use the student table to get a list of possible student numbers. We can even set the sort order, and we can adjust the width of the column. And finally, we want to link this element to a field in the grades table. So in other words, when I add or change a record using this form, it's going to store the value I pick here in the student ID field. And of course, we have to pick a name for this combo box. And let's remove the original field and drag and drop the brand new combo box in its place. This way, any user using this form won't be able to add an invalid value by mistake. It also makes sense to add a combo box for the subject, and I recommend that you do it yourself as an exercise. We can also resize the form quite easily. And we can also add a button. With buttons, we can add all sorts of functionality, like for example, go to the next record or go to the previous record. And we can also add radio buttons using this element. With radio buttons, we can add different options. But in this case, it probably makes more sense to talk about grades from 10 to 1. And we can link each option to a value. And next we specify which field the value will be stored in. And we can also change the appearance of the radio buttons. Note that in this case though, we cannot change the value of the radio buttons. That's because they're linked to a calculated field. But if this was not a calculated field, we would be able to set these values using this form. Okay, so let's have a look at what we've covered. We've covered radio buttons, drop-down menus, form controls, buttons in other words. And next let's talk about fonts and styles. To change fonts and styles, you can go to the design view and you can use the properties sheet. Remember, you can activate the properties sheet using this button here. Just select the element where you want to change some properties and then find the property in the properties sheet. Or even easier, you can find a lot of formatting options in the Formatting tab. So that brings us to spacing between fields. We've already learned about using the Arrange tab to create a grid layout, to create rows and columns for our fields. And with that, we can easily adjust the spacing. We can also move individual elements around without using this grid. When it comes to forms, it's very important to think about how your form layout is to make it as user-friendly as possible. This basically covers spacing between fields and also covers the use of white space. Essentially, when it comes to white space, they're talking about like line spacing and margins. You can set line spacing and margins in the property sheet. When it comes to character spacing, they're simply talking about the space between individual characters. Obviously, It has to be not too much space, and obviously the letters shouldn't be overlapping either. In MS Access you can't really change that setting, and it's kind of unusual that they put that in the syllabus, but it just maybe might come up in paper 1. But it certainly won't come up in paper 2. So let's move on. Next, let's talk about highlighting individual fields. To highlight individual fields, we just use a property sheet again, and there's a back color there. We can easily set the back color in this way. Incidentally, you can also achieve the same thing using the Format tab. So that's it. Next, let's talk about creating linked subforms. So I've created a new very simple form, and the first thing I'm going to do is make a bit more space, and I'm going to just click and drag the grades table into the form, and voila, we have a very quick subform. We can also drag pre-existing forms onto our form to create a subform. And that's it for forms. In fact, when it comes to forms, there's only one more thing we need to talk about, and that's called calculated controls. To demonstrate, we add a simple text box, select it, and go to the property sheet. We go to all properties and arrange it by alphabetical order so that we can easily find the property control source. Not all elements have this property, but those which do, we can create calculated controls. To do that, we click on the dots here to open up the expression builder. As we learned about the expression builder, we can use it to build all sorts of equations. In this case, let's convert the grades field into from a percentage into a score out of 10. These kind of calculated fields can be a quite useful guide to help the user fill out the form. And that's it for calculated controls. Finally, on the very last topic, we are going to talk about switchboards. A switchboard is simply a menu. So let's say you've worked very hard to create an advanced and complicated database with a lot of queries and a lot of reports and stuff like that. And somebody who's new or who wasn't involved in designing the system won't really have a good overview on how to do what. So what you can do is create a menu or a switchboard, and you can have one button for creating reports for students' grades. You could have one button for opening another form. You can have one button for starting a query for all failing students, for example, or you could have a button for creating a query that finds all exemplary students, etc., etc. The first time we create a switchboard, we need to go up to this little triangle here and go to More Commands. And then under More Commands, we search for All Commands, and we scroll all the way down to S, Switchboard Manager, and click on Add. And now we can start up the Switchboard Manager with this icon all the way to the top left. And since it's our first time creating a new switchboard, just click Yes. This opens the Switchboard Manager. We already have the default switchboard. We can create a new switchboard, or we can edit this existing switchboard. We can change the name of the switchboard, and we can add functions or commands. These are going to be the buttons. We can set the text of each button, and then we have a bunch of possible commands. For example, open the form in add mode. So now let's create a bunch of functions to add to our switchboard. Remember, we can always edit any of these buttons whenever we want. It makes sense to give them names which are easy for any user to understand what they do. Now that our switchboard is done, we see that a table has been added and a form has been added. When we open up the form, we get this, which doesn't look pretty, but it works. For example, we can use it to open up form 1, which is an empty form. Let's close it again. Design application will open the switchboard manager again, but we need to close the table first. So let's do that and see if the button works. Yep. And we can also open the report we created earlier. We can also create sub-switchboards. So for example, we would have multiple switchboards, one switchboard for HR, one switchboard for teachers, one switchboard for management, etc., etc. And we would put all switchboards inside the main switchboard, so that the main switchboard we would be able to choose which switchboard we need. To demonstrate, let's first create a new switchboard. So let's create one for HR related commands. And let's put in some commands like open report and one more. Let's just put in some fake commands for the sake of illustration. It doesn't really matter what we put in, but it's a good idea to get a feel for what kind of commands are listed here. And when we're done, we go back to our main switchboard and edit it, and we just add the switchboard we just created. And let's name it Go to HR switchboard. Move it all the way to the top. And let's refresh it by closing it and opening it again. And here we see we have a switchboard within a switchboard. And that brings us to the end of the video. We've completed our checklist. I hope this video was helpful to you, but remember, it's certainly not sufficient by itself. I hope you've been following along and doing all these examples with me, but even that is not quite enough. I highly recommend that you get some exercise. If I have sufficient time in the future, I may create a walkthrough through some of these exercises, which we can find in the book, or some of the specimen paper exercises. Anyway, that's it from me for now. Thanks for watching, good studying, and good luck on your exam. Bye for now.